2 billion people open this app today, and not one of them has ever seen what's actually underneath it. Let's start with just how big this thing actually is. Start with the size of the thing. In September 2025, Meta said Instagram had crossed 3 billion monthly users, up from the 2 billion mark Zuckerberg cited just 3 years before that. A billion more people in 3 years. Instagram doesn't publish daily numbers like that anymore. But the last time it did, back in 2016, the company said 95 million photos and videos were shared every single day. Something like 1100 uploads a second every second on a platform 6 times smaller than it is now. And there's a target sitting underneath all of it. 19.99% uptime. That sounds like a rounding error until you do the math. It means the entire system is allowed about 52 minutes of downtime total across an entire year. So how do you actually build something that big? Let's open up the architecture. Every request, a login, a post, a like, comes through the same front door, an API gateway that checks who you are, how fast you're allowed to ask, and where the request actually needs to go. Each of those services does exactly one job and nothing else. IOUth handles logins and two-factor codes. User owns your profile and your follower graph. Media handles nothing but files. Feed only ranks. Search only finds. Messaging only delivers. Notifications only decides what's worth interrupting you for. Meta's own engineers have confirmed it directly. Instagram runs one of the largest deployments of Django and Python anywhere in the world. A framework chosen back when the whole company was a dozen people who needed to ship fast, not scale first. That choice is still paying rent more than 15 years of traffic later. Let's follow a single photo and see exactly where it goes the moment you hit post. So, follow one photo, not a metaphor. The actual path a single upload takes, hop by hop, before it ever reaches a follower's screen. It hits the gateway first, gets authenticated, and gets routed straight to the media service. The one system whose entire job is handling files, not opinions. The raw file lands in object storage untouched. Then a transcoding pipeline spins up multiple versions of it in parallel. While the metadata, who posted it, when, with what caption, gets written to its own database entirely. Once that's done, one event gets published to a queue, and that's what tells the feed service, the notification service, everyone downstream, that something new just happened. All that data has to live somewhere, and not every piece belongs in the same place. Here's something that surprises people. Instagram doesn't have a database. It has at least 6, and each one exists because a single database would have been wrong for at least one of these jobs. Profiles live in Postgres because a profile needs to be exactly right every time. Likes and comments live in Cassandra because that's an ocean of small rights that never really needs to be perfectly consistent, just fast. And your social graph, who follows whom, lives in a graph database built for exactly one kind of question: who's connected to who? And none of these 6 homes treats all of its own data the same way either. Recent data stays in fast, expensive storage. Older data, a photo from 3 years ago, nobody's looked at since, automatically slides into a cheaper, slower tier built for exactly that. Things you might need someday, not things you need right now. And then there's the feed cache, Redis, sitting in front of all of it because whatever else is true, your feed has to load in under 10 milliseconds, or none of the rest of this matters. So how does your feed actually decide what to show you first? Let's look at how it's ranked. Back in 2016, Instagram made a change a lot of people hated at the time. It stopped showing posts in the order they were posted. The reason came straight from the company itself. Under a purely chronological feed, people were missing an average of 70% of the posts from accounts they actually followed. So instead, every candidate post gets scored: how recent it is, how likely you are to engage based on your history, how close you actually are to that account, and whether showing it keeps your feed varied instead of the same 3 accounts over and over. The pipeline itself is simple to say and expensive to run. Pull every eligible post from everyone you follow, score each one against a model, apply the diversity rules, and hand back one ordered list. And once that list exists, Instagram doesn't rebuild it from scratch every time you open the app. New posts just get appended to what's already sitting in your cache. That's part of how a feed this personalized still loads in under 200 milliseconds. But what happens when one account has more followers than most countries have people? That whole system, pre-compute the feed, push it to a cache, append a new post as they arrive, is called fan out on write. And for the overwhelming majority of accounts, the ones with a few hundred or a few thousand followers, it's brilliant, sub 100 millisecond loads every time. But somewhere out there is an account with 500 million followers. Post from that account and push it to every follower's cache immediately. Stops being brilliant. It becomes 500 million writes all at once, all triggered by one tab. This is the celebrity problem. The exact mechanism that makes a normal person's feed fast is the same mechanism that would melt the system under a famous one. So there's a second approach: fan out on read. Instead of pushing a post to everyone the moment it's made, the system waits. When you actually open the app, it looks at everyone you follow, pulls their recent posts on the spot, and ranks them right then. That approach never wastes a single write on someone who never opens the app, but it costs you at read time instead. And if you follow a few thousand accounts yourself, that read can get expensive enough to blow past the 200 millisecond target. So Instagram runs both at the same time and switches between them based on one number, your follower count. Cross some threshold and the system stops pushing your post to every cache immediately and starts computing your feed's presence fresh for every viewer instead. Instagram has never published exactly where that line sits. Twitter has publicly in a 2013 engineering talk about this same exact problem, somewhere around 10,000 followers. Different platform, same fork in the road. Nobody sat down and designed one clean system for this. They built two and taught the platform which one to use for you, specifically based on who's watching. That's what most of the real hard problems in a system this size actually look like. Not a bug, a trade-off somebody chose on purpose. Before any of that even reaches Instagram's servers, your phone's already doing some of the work. Before a single byte reaches Instagram's servers, your own phone has already compressed the image or video. And for anything large, it's broken into chunks and uploaded in parallel. So a bad connection only has to retry the pieces that actually failed. Once it's whole again, the transcoding pipeline takes over. The same upload becomes a 1080p version, a 720p version, a lower quality fallback, encoded in a newer, 30% more efficient codec for phones that support it, and the older standard for the ones that don't. And every step of that pipeline is written to be idempotent, meaning if a worker crashes halfway through transcoding your video, running the exact same step again produces the exact same result instead of a corrupted one. At 1,000 uploads a second, something is always crashing somewhere. The pipeline just doesn't care. Let's shift to something everyone uses but almost nobody thinks about: the search bar. Every username, hashtag, caption, and location gets indexed continuously so that something posted minutes ago is already searchable. Not tomorrow, not after some nightly batch job minutes. That index has to forgive typos, guess what you meant halfway through typing it, and quietly favor results based on what you've searched for before, all before it even gets to deciding what's actually relevant. Before any of that ranking happens, there's a whole layer just for understanding the question itself, expanding it with related terms and synonyms you didn't type, quietly fixing the spelling, and leaning on your own search history. So the same three letters mean something different to you than to a stranger. Now here's the harder problem. How do you recommend something you've never even searched for? Explore works completely differently from search because nobody's typing anything. The system has to guess what you'd want to see out of literally everything on the platform. It starts by pulling in millions of loose candidates, trending content, things people like you have liked, posts from accounts adjacent to ones you already follow. Most of those millions get cut fast and cheap. Simple engagement counts, basic categories, nothing that costs much compute, until only thousands are left standing. Only on that much smaller set does Instagram spend the real money, deep engagement models, computer vision that actually looks at what's in the image, your full preference history. That's the level where it's worth being expensive because there's so much less left to score. And it's not one model doing this everywhere. Meta's own engineers wrote about it directly in a 2025 post literally called Journey to 1000 Models. Instagram runs over 1,000 specialized models across feed stories and reels alone. Explore runs its own separate stack on top of that, tuned for exactly where you are in the grid. And just like your feed, the expensive part gets cached where it can be. Trending hashtags, popular accounts, whole recommendation sets for common types of users. All pre-computed and sitting in Redis, only thrown out and rebuilt when the signals underneath them actually shift. Stories work completely differently from the feed, starting with the fact that they're built to disappear. A story has one property nothing else on the platform has. Everyone who's going to see it needs to see it right away, and in exactly 24 hours it has to disappear. Not roughly, not eventually. Exactly. That precision is harder than it sounds. Content visible at 23:59:59 has to vanish exactly 1 second later. And if every server just trusted its own internal clock, some stories would outlive others by accident. So the timing runs off a shared central clock, not whichever machine happens to be serving your request. And for a popular account, millions of people can view the same story. So instead of tracking every single viewer perfectly, the system leans on probabilistic counting for the big numbers, trading a little precision for the ability to handle it at all. The app doesn't wait for you to tap a story before it starts loading one. A prediction model watches which accounts you actually interact with and quietly prefetches those stories in the background. So by the time you tap, it isn't fetching anything, it's already there. And even the video itself doesn't wait to be fully downloaded. Playback starts on the lowest quality segment immediately, while higher quality segments keep buffering in behind it. You're already watching before the story has finished arriving. Let's talk about the feature that started as an afterthought and quietly became half the app: direct messages. Somewhere along the way, direct messaging stopped being a side feature. Instagram's own head of product said it plainly in 2025. More photos and videos get shared into DMs than into stories, and more get shared into stories than into the public feed. Sharing on Instagram has quietly gone private. A message goes through a gateway of its own, gets queued for delivery, and gets stored in the same append heavy database that handles likes and comments. because a message structurally is just another fast, constant write. If you're online, it reaches you instantly over a connection that's just sitting open, waiting. If you're not, it waits as a push notification instead. And unlike a story, a conversation doesn't have an expiration date. It's kept indefinitely. Recent messages stay in the fast tier, so scrolling up feels instant. A conversation from 3 years ago slides into the same, cheaper archive tier the old photos live in, and gets pulled back only if you actually go looking for it. And an increasing share of those messages are now end to end encrypted, meaning even Meta itself can't read what's inside them, which creates a strange problem. How do you catch spam in a system you've deliberately built to be unreadable? By watching everything around the message instead. How often someone messages, how many different people, how old the account is, never the words themselves. One more thing worth understanding: how does Instagram decide when to actually ping you? Every like, comment, follow, and mention could technically trigger a notification the instant it happens, but 11 separate pings in 1 minute won't make anyone feel engaged. It'll make them turn notifications off entirely. So instead of one fixed rule, Instagram runs this through a machine learning model. Meta's engineering team has written about this directly, that scores every single notification moment and decides case by case whether it's actually worth interrupting you for. A burst of likes usually collapses into one alert. A direct message or someone mentioning you almost never waits. And notify isn't one button. It's a push alert, or an in-app badge, or an email or a text, each with its own latency and its own cost. The system leans harder on some channels for people who never open the app and barely bothers with others for people already inside it every day. Zoom out for a second, because none of this works unless it survives real traffic at scale. For most of what happens on Instagram, people read far more than they ever write. Roughly 100 views for every single post made. Which means the entire system is really optimized around one question: how do you serve a read without ever touching the real database? If you can possibly help it. The outermost layer is the CDN, content sitting at edge locations, physically close to you. So a viral video watched a million times never has to reach back to a single origin server a million separate times. Behind that sits Redis and Memcached, holding the hottest data, recent feeds, profiles, post metadata, and that cache has to hit correctly more than 99% of the time, because every single miss means a real database query and real load. And underneath all of that, the actual databases are split, sharded, across many machines using consistent hashing. So adding or removing a shard doesn't mean reshuffling everything else that's already there. Not everything has to happen while you wait. Anything that doesn't need an answer right now, ranking updates, analytics, the heavier housekeeping, gets handed to a queue and finished later off to the side. So the request that's actually waiting on you gets its answer fast. And a few times a year, none of this is theoretical. Traffic can spike 3 to 4 times normal within minutes. New Year's Eve, a election night, a cricket final. The system doesn't scramble in the moment. It pre-warms extra capacity ahead of the predicted spike. And if things still get tight, it quietly drops the nice to haves first, keeping the core experience alive. Last piece of the puzzle: how does Instagram know it's actually you logging in? Before anything else happens, the system has to believe you're who you say you are. A password check through OAuth, a second code from your phone, if you've turned that on, and a quiet fingerprint of the device and location you're logging in from. Log in from a new country at 3 am, and it notices even if you never do. Nothing in this system trusts anything else completely. The gateway checks who you are, The databases encrypt anything sensitive on their own, and the logs themselves are built to scrub out anything personal before a human ever reads them. Everything moving between your phone and Instagram servers travels encrypted, and anything sensitive sitting at rest in a database is encrypted again separately. That's two independent logs, not one. So even if one layer were ever compromised, the other still holds. And when the system catches something wrong, it doesn't reach straight for a permanent ban. It escalates. A capture first, then a temporary block, and only after a pattern of real abuse, something permanent. And underneath all of it sits a quieter requirement. If you ask this system to delete your data, it has to actually be able to find every copy of it across every one of those 6 databases and prove it's gone. That's not a feature, because that's what regulations like GDPR and CCPA require by law. So the next time you post something, remember what's actually happening underneath it. 6 different databases, 1,000 ranking models, and one quiet decision made the instant you hit share about whether your follower count means this goes out one way or a completely different one.